This conference will now be recorded.
Right. We'll start with the beginning of the first unit called as Introduction to Data Communications. So here let's start with what do you mean by it? What do we understand by data? Then we'll start understanding the basic terminologies related with data communications. And then we'll try to understand what do we mean by a network and the categorization of the networks. First, let us start with discussion with data. When generally we use a term called telecommunications, which is basically refers to communication between devices which are at a distance. Tele refers to the distance and communication means exchange. Now the exchange which is happening between the two devices is in the form of the data. Then we are going to refer the communication as data communication, right? And to make this communication happen, the devices, that is the source and the destination, maybe either will be connected through a cable or it might be wireless. That connection between the source and destination is referred as the transmission medium through which this data is going to be transmitted. Fine. Now, let us start understanding what is data and what are the different forms in which a data exists. So data refers to the information that is going to be exchanged between the source sender and the destination with the receiver. Now the data which can be exchanged is in different formats. For instance, I'm using a simple messenger where I'm trying to exchange some small messages. I want to say hi, how are you? So this is a simple text message which I would like to send to my destination device, right? And sometimes I would like to send him some amount in form of numbers. So the data here can be in form of 0 to 9. But remember, though the data is in either in the text format or in the number format, it has to be converted into a series of zeros and ones. Now look at the example of a WhatsApp. Instead of text or a number, there is a chance that we will try to share certain images which have been useful, sometimes fun jokes, or some information about any webinars. But when you try to exchange or your personal pics, and you want to exchange, the data which we are trying to exchange is in form of images. And we are going to represent images in form of pixels, which are going to be later converted into this series of zeros and ones. Now fine, does we just send image, text, or so-called numbers? No, we exchange a lot of videos, right? I hope we will understand. We try to put some short jokes and or sometimes it will be some songs kind or some skits kind. We try to exchange a number of videos between among us, right? So the one more form of data which is generally exchanged is referred as the video format. And the last but not the least, we can have the data in form of a simple audio, right? I want to send you a song sang by me. So I just select the mic button, I try to sing it, and I try to send you. So the data which I can send is in the form of an audio signal. So hence, here what we would like to make you understand is the data which we are trying to exchange between the source and the destination can be in form of an text, numbers, image, audio, or video. Right. I hope we people are clear with the terminology called what do we mean by data and the different forms in which the data will be represented. Right. So after, and I hope everyone are clear with this. Right. So next shall we forward to the what are the different components involved in a data communication. Now, we have been talking for a long time. A simple example of me sending a simple text message to my friend. So what are the different components which are involved in this exchange of data, right? The first and most important thing that we require in data communication is a sender who has to generate the information. So the first important component is the sender who generates the message. And the second important element here is what do we want to send? In what form it might be? We have just discussed the different forms of information. The information which you want to communicate to the destination, we are referring to the term called message. And now, the message which is generated by the sender to reach to the destination, it has to travel through a certain path. The path which is used for transmission of information is referred as communication path or transmission medium. That is the third important element. Now the information has been successfully reached to the receiver, the element or the device which to whom we are actually trying to send the device information. We refer it as destination or receiver. Now, the most important, the fifth one, which we have to understand is to send the information from the source to the destination, we definitely need to follow certain set of rules and procedures that guide us how the data communication has to happen. Those set of rules which we have been using, here we refer it as protocols. And this is what we are going to discuss in more detail, their functionalities. At the same time, what are the different protocols we are using at different layers of our TCP IP model. So just remember in one line, protocol refers to set of rules and procedures that govern the data communication, right? I hope the things are clear. So totally they have 5 components of data communication system. The one who generates a message called as source, the information to be exchanged called as message, the transmission path through which you want to send the information, that is called medium, the one to whom you are trying to send the information, you call it as receiver, and finally, the most important, the set of rules and procedures that govern the communication between the sender and receiver, which we refer to as protocol, right? I hope I'm clear. So first we try to understand what is data and what are the different forms of data. And next we try to understand what are the different components in part of a data communication. Now, we have been talking about exchange of information. Does the exchange of information happens only in one direction? Or exchange of information happens in two directions? Then what? So based on the direction of exchange of information, we categorize the networks into 3 types. The first one, which is called as simplex, is a one in which you just try to send the information from right. The first one is called as simplex, where you just try to communicate information from one direction. So there will be only one sender, and at the same time, there will be only one receiver. There will be no other way of communication. The best example for this is a radio, where you just try to transmit, and your receivers, the radio station will transmit, and the radio receivers will just receive. And there is no reverse communication. And second mode here is there is a flow of information between the two stations. But what is the condition here is two stations can send the data as well as receive the data, but they cannot perform both the functions together. Means if you are a station and you are trying to send the data, then you cannot receive the data. Similarly, when you are a receiver and trying to receive the information, you can only receive it and you cannot transmit the data. This kind of communication we are referring it as half duplex. Duplex refers to two directions, but half because you can at any instant of time you can only perform only one function. Am I clear? Right. The third case is a scenario where a station will be acting both as a sender as well as a receiver at the same time. Means the direction of information will be in both directions at the same time. So what is our real-time example? For instance, you are having a conversation on a phone. So you are trying to send the information to your friend in format for audio. At the same time, you are trying to listen to what he's talking. So here you are receiving. So the information in form of audio has been transmitted as well as received. So when both activities happen together, the kind of data flow. And the network we have been talking about is referred as full duplex network. I hope we people are being clear about what we have been understanding, that we are categorizing different networks based on the direction flow. Here we have a simple video which actually demonstrates with an example how this communication between the devices is happening. Let me just play it for you. Here you can find a simplex where the data transmission is only in the one direction. The example is the radio station. Then it's a half duplex, which is your walkie-talkie. Fine, the communication happens in both the directions, but only one at a time. If you are sending, then you cannot receive. If you are receiving, you cannot send it. And third ways is your mobile communication, where you have both ways of communication happening parallelly. This is what full duplex refers to. Right. So I think this is also clear. So we discussed about what is data, and then we try to understand what is data communication, what are the components of a data communication, and then how we are going to classify the networks based on the direction of data flow. The next we are going to introduce you about the networks. And what do you mean by network? How you're going to evaluate a network? Then you're going to talk about what are the different types of networks, and then we are also trying to talk about how we are going to connect different devices in a network. First, let us try to understand the meaning of term network. Simple. So I want to highlight the definition of network. A network is a set of devices, and here the devices are often referred as nodes connected by a communication link. Right. Now, what do you mean by it? For instance, I have four friends. Now, whether they are a network or not, you have the four friends can be treated as four nodes. And if we are trying to connect them using some network, like these four friends are connected to a common WhatsApp group, means they are part of network. The group that we are talking about is a link. What my point? So a network is nothing but a group of devices which are connected by the link. And what kind of devices are we referring? We are trying to refer the devices which have a capability of sending the information at the same time receiving the information. And the link which we are trying to talk to connect about the various devices can be either the wired cables or it can be a wireless links. But the important thing is devices are said to be a part of network when they are connected to each other by some sort of link. Okay, right. If you are clear with this definition, what do you mean by network? It's a simple, a group of devices connected by a link, right? Okay. The first term which we need to understand related to network is distributed processing. For this, I would just like to take a small real-time example. For instance, few people are preparing for a festival at your house. So once it is a festival, you know there are a long number of activities. For instance, if your mom has to do all the work, then definitely it becomes a lot of burden to her and it would take a lot of time. So what is suggested in this scenario? Instead of mom trying to do all the works related to the festival preparation, the works are divided into smaller units and we people share some of the works and make sure all the works are completed and also the burden on the mother is reduced. And the other benefit we get here is When the amount of work is limited, people do it with perfections. So similarly, when we are talking about earlier computers like the mainframe computers, all the work has to be done by a single computer. So it was a lot of burden and it was taking a lot of time for completion of all the work. So the performance was not up to the mark. So what we have done is, instead of one large mainframe computer performing all the works, the total work to be done is divided into smaller units called processors. And we have a smaller systems with processors which would be performing those activities. Because of this, the burden on the mainframe computer got reduced. At the same time, the amount of time required to complete all the activities got declined. And those particular systems have become experts in doing particular tasks, which through which we also got some expertism in the implementation. Now, dividing a larger work into smaller units and then assigning different systems or processors to complete those particular works, we refer with the terminology called distributed processing. I hope I am clear on this. So we try to understand what do we mean by a network, and then we try to understand what do we mean by a distributed processing. Okay, fine. Next, we have been trying to understand what do we mean by a network and how do we implement and establish a network. Now, someone would like to talk about the mobile saying that my network is good, my network is bad, I get good service in my network service is poor. So what do you mean by it? For instance, we talked about mobile networks. Someone says that I have a stupid network. It doesn't know where I could get its signal coverage. There's someone says that my network is too good. No matter wherever I go, I get a good signal strength. Or someone says that I have the worst network being used because the data rate is too poor. And the other says I have a wonderful network, a large data rate and unlimited download allowed. So we are trying to measure a cellular network performance in terms of signal strength or the data rate supported. Similarly, different networks which we are going to discuss have certain criteria through which they are evaluated. And what are those criteria which we generally use to evaluate a network? The first one is performance. The next we have is reliability. The third one is security. So what do we mean by performance, right? For instance, I have parameters like delay and throughput, which indicates the performance of a network. Simple. You send a message in the morning, and in no time, if that message is reached to your destination, you say that the network is good and there is no delay. But if I send it in the morning and unfortunately the receiver has got that message in the afternoon, or I sent a mail in the morning and it reached some very late to your receiver and you could not get the work done. So what do you say? There's a lot of delay and my network is too bad, right? Same time, if I'm trying to send data in form of smaller units called packets, and in the total data which I have sent, some of the data has been lost. If I send data in form of packets of 100, and only 90 packets have been received. So what is the success ratio? So 90 out of 100. And what is the packet drop ratio? 10 out of 100. The success of packets to the total transmitted packets, we refer with a parameter called throughput. And the number of packets which are lost during the transmission, we refer with a terminology called packet loss. So these are the criteria for which you try to measure the performance of a network. Clear? Right. So next criteria through which you try to determine the performance of a network is reliability. For instance, you are using an Wi-Fi connectivity at your home. In a day, for half of the day, if you are not able to connect to the network, what do you say? Ah, stupid Wi-Fi I have. We need to change our net ISP because it's always down for a long time. So what do you mean by reliability? Amount of duration for which the network is active, that is what you refer with the terminology called reliability. But and Third important one is, if I am sending some confidential data through my network, is that data secured, or there is some chance that my information which I am exchanging is being hacked by someone else? So that is an important criteria. So while doing an commercial transactions, it's necessary that we do those in networks which are having secure. And when you are visiting different websites, please check down that the websites which have a phrase HTTPS, where S refers that that particular website is secure. So security is also one of the important parameters to evaluate a network, right? So these are the different criteria which we try to consider for evaluating a network. Clear? Right. Now, coming back to the definition of network, we discussed like devices which are or the nodes connected by links. So we need certain links to connect devices. Sometimes a link will be exclusively used to connect two destinations or two nodes. So if that particular link is dedicated to two particular stations, then the kind of the link used is referred as point-to-point link. And there is another scenario where a particular link will be shared by more than one station. Something like they want to make effective utilization. What is the best example to understand this multi-point scenario is highways which are trying to connect different places, right? So same highway will be shared to connect different villages. I start from Hyderabad to Vijayawada, but the people who are traveling from Hyderabad to Suryapet or Hyderabad to Kodad can also use the same road. So that is what a simple multi-point configuration, right? And to connect the different devices to the multi-point link, we are using taps. Here we are using device called taps. With the help of that, we are trying to connect to the devices. Okay, so the types of connections used in the network can be point to point or multi-point, right? Next, we have a very important terminology called topology. So here we have discussed about types of connection. The next important slide talks about topology. But what do you mean by topology? Is, for instance, you have 4 to 5 devices, and the way you want to connect those devices in the network, we refer it as topology. Now, based on the way we are trying to connect those devices, we have different types of topologies. The one best way to understand a term called topology is the way students sit in the class. The way they sit during the lunch hour is different. The way they sit during a class hour with the faculty's presence is different. And the way they sit during the exam time is different, right? The way they sit in the buses will be different. The way they sit in the canteen will be different. So I'm talking about same devices, but they are being arranged in different ways. Of the way these devices or the nodes are connected, we are referring with a terminology called topology. And we have different types of topology based on the way the devices are connected. The first and most important type of topology is mesh. Then we have star. Then we have ring. We have bus. And finally, a topology which is a combination of all these four, called as hybrid topology. Let me start with mesh. This is the first type of topology in which every device is trying to connect to every other device in the network using a point-to-point link. Now, what is the advantage here is the link will be exclusively dedicated to the particular stations. But what is the complexity? Now, for n number of devices, the total number of links required is n into n minus 1 by 2. For the example which is shown in the figure, you have 5 devices, and to connect all the devices using mesh topology, the total number of links required are 10. That is 5 into 5 minus 1 by 2. Okay, so let me make it 1. So this divides 1. So we have 1, 2, 3, then 4. And coming to station 1, it's already connected. 5, 6, and 7. Then for station 3, already we have specified this. So this is 8. Then we have 9. And this is referred as 10. So you can find totally 10 links are required to connect 5 devices. For instance, I got 100 devices in the network. Total number of links required is 100 into 100 minus 1 by 2. So it's almost 50 into 49 is nothing but 2450 links. To connect 100 devices, I need 2450 links, which is a big factor. And more the devices, the complexity increases, right? So to overcome this problem, we move from mesh topology to the next type of topology called star topology. Now here also we are going to use the same point-to-point links what we have used in mesh topology. So what is the difference is, instead of each station connected to every other station, they have been connected to a central controlling element called hub. So all the connections are made to the hub, and this will actually control the communication between the devices. Now this, the best example in our class scenario is during an invigilation. Each student cannot talk to the other student in the exam. So how they are trying to communicate? So they take the help of an invigilator and they try to ask him that they need a particular source from the resource from the other person, and he tries to make the communication or the exchange of the things. So here the invigilator plays the role of the hub, and whereas the students are playing the role of the station. So all stations are directly connected to the hub. The advantage here, for 4 devices we just require only 4 links, right? So how many links are required? Just 4. 1, 2, 3, 4. So the complexity got reduced. But what is the drawback is there is a delay in the communication. When one is trying to connect to 2, and at the same time 3 want to connect to 4, so there will be a delay in the communication because hub is engaged in communication for 1 to 2. This is one thing. And second problem arising here is, if hub is damaged, so total communication between the devices get interrupted. That is the thing that we need to be taken care. The third type of topology is one where we are going to use multi-point connections. Means a link will be shared between more than one device. Now here we have a link running between the 2 points. That link will be shared by more than one station. And how we are trying to connect the stations to this common link? By using a drop line, and for the link we are using certain taps. But the best advantage we get here is the cost involved will be less, and also the earlier problems mentioned like number of connections and also the cost involved, requirement of a hub, all get reduced, right? And the highway networks which we are talking about is the best example of bus topology. And the last fourth kind of topology is the one in which all the nodes are arranged in form of a ring, right? And next important thing here is every device in the ring topology is connected to its predecessor, means the one which comes earlier, and its successor through 2 dedicated point-to-point links. For the point, so every station is connected to 2 other stations. And remember, basically ring topology is a unidirectional communication, and the direction of communication is in the clockwise direction. For instance, in this we got 6 stations. Let me number it as 1, 2, 3, 4, 5, and 6. Okay, right. So among the 6 devices, if one would like to communicate to 4, but do we have a dedicated point-to-point links? No, because one is only connected to 2 as well as the device 6. So what happens? So station 1, which will be transmitting the data to station 2. But what is the destination? Station 4. What happens? Station 2 looks at the destination address, finds it is not 2, so it has to forward the data to the 3 because it actually received from 1. Now, before 2 transmits the data to station 3, it actually possesses a device called repeater, which regenerates the data and then transmits to the destination. Now the information will be transmitted from 2 to 3, but 3 is not our destination. Again, it verifies and then understands it is not intended, the data is not intended to it. So it has to forward it to the next station called station 4. It repeats the process of regeneration using its repeater, and then the data will be reaching to the destination 4. Now it is matching to the destination address, so it will take the information. So this is how an information is exchanged in a ring topology. The advantage, we got a point-to-point link, and total links are comparatively less, and there is no need of a special equipment like hub in the star topology. But what is the problem is, first thing, if the communication is between the devices 6 to 1, it happens in simply one transaction. But if the communication has to be happened between 1 to 6, it's a unidirectional. So what happens is the data has to be transmitted from 1 to 2, 2 to 3, 3 to 4, 4 to 5, and finally 5 to 6. So the amount of delay will be definitely high. One more thing is for communication to start, and if the link between 1 to 2 got disrupted, can we have a communication from 1 to any other device in the network? No. So to overcome this problem and to provide what we say reliability, what we try to do is we try to provide an alternate ring called dual ring operating in the anti-clockwise direction, and that will be active only for the duration when the main ring topology is in the inactive phase. Got it? So this is how we try to implement a ring topology. And we started with mesh, then we discussed about star, then we talked about bus, finally we talked about ring. And sometimes, and most of the times, as the network grows, we can't just implement one topology. It is our necessity to adapt more than one topology in our network. We may have a bus, we may have a star, we may have a ring, we may have a mesh. Now, for instance, in this particular figure, you could find two types of topologies have been involved. First, a link is shared by more than one station, which indicates a bus topology. So similarly, the three links are not directly connected. So they are connected to a central controlling element called hub. For instance, if this is the station 1, would like to communicate to a station 9. First, let me erase the previous. Okay, so let me start. This is the device called A, and it would like to communicate with the device called H. Now, these two, A and H, are not directly connected to a link. So what happens is, A will be trying to transmit the data through its link to the hub, and hub identifies that the destination H is connected to the link 3. So let me put numbers for three links as 1, link 2, and third as link 3. So our source is connected to link 1 and our destination H is connected to link 3. So this is how the connection has to be transmitted. So in this diagram, you could find more than one topology with three bus networks, and finally all these three bus networks connected to it, one star topology. And this kind of topology is referred as hybrid topology. I hope I'm clear. This is one of the very important questions in the exam, and I hope everyone understands this topic. Right. Now we were talking about network as a set of devices or nodes connected by links, right? So to make and devices which we are talking about may not be of same models. They may be of different manufacturers, but still they need to be having a communication between the devices. So this kind of communication between devices made of different manufacturers is only possible with the help of certain standards and models. So in our data communication, we have been now using two different types of models. The best standard model was developed by International Standard Organization, and the model was referred as Open System Interconnection. And in this particular model, we have 7 layers, namely application, session, presentation, transport, network, data link, and physical layer. And when you compare this with our second alternate model, we have only 5 layers. So the small difference in this OSI and TCP model in terms of layers is the presentation and session layers, which were separate in case of OSI, are combined with application layer in the TCP IP model, and we have only 5 layers called application, transport, network, data link, and physical layers. So we'll talk more in detail in our next class, but let us try to understand this. Now, a network which is trying to connect, sorry, a network which is trying to connect different devices has been categorized based on the distance between the source and destination or the number of devices which are part of the network. But here we are trying to categorize based on the distance aspect, right? And based on the distance between the source and destination, we are trying to categorize the networks as local area network, metropolitan area network, and wide area network. Now, if you're trying to talk about a simple network connecting devices which are part of it within the building or between two buildings in the same premises, then the kind of networks are referred as local area network. But the same scenario, you are trying to connect two buildings or two offices of a particular company which are located at two different places in the same city. Then the type of network we are referring is called as metropolitan area network. But now, if you are trying to connect the two offices of a company which are located at two different cities or two different countries or continents, then the type of network which we are trying to establish, we are referring it as wide area networks. I hope terminology is clear for us. First covers with two building within the building or adjacent buildings. We call it as LANs. So the next covers within the city. We call it as metropolitan area network. And if it is trying to connect offices between different cities or places or countries or continents, we refer it as wide area network. As we stated earlier, local area network in this figure could try to connect different systems which are a part of a building. And what is the basic purpose of connecting systems in a LAN? Why do we need it? For simple instance, you go to our lab, all they are connected to the LAN. Why? For instance, if you are trying to connect all different systems to a network, you can try to share the resources between those devices. The resource may be some simple hardware or software and a license tool, Or you can say that all the systems are connected to LAN and one of the system is connected to a printer. Then we can try to able to queue print from all the systems to that single printer. And this is only possible when all the devices are connected to a local area network. I hope I'm getting here right. The second scenario, let me get back. The second scenario we need to talk about is when you are trying to connect two different offices of a company which are located in the same city. Means the distance between them might be some 50 kilometers or 60 kilometers, and you are trying to connect to them. Then the type of network you are referring to is called metropolitan area network. Now earlier, one of the best ways to understand the example is the cable network, which was only exclusively used for aerial transmissions. Now we are trying to use the same cable network for even the provisioning internet facilities, right? So that is for digital network, which we have been talked about. Okay. And next, most important one is when you're trying to connect which devices which are very far from each other. And those type of networks will be called as wide area networks. And to implement wide area networks, we have two different strategies. When you're trying to connect the two different devices or the two different stations using a point dedicated laser line kind of connectivity, then we refer the type of network as the point-to-point WAN. But in case if you're trying to connect the different devices, that is the source and destination, with the help of a number of intermediate devices such as routers, then the kind of network will be referred as a switched WANs. Here the routers will act as switch. They are called as three-layer, third-layer switches. And when you're implementing a WAN using the switches, we refer it as switched WAN. When you are been using a dedicated point-to-point laser line to connect the two devices, we call it as point-to-point. So I hope we could understand how we categorize our different networks based on the distance between the source and the destination, as well as the number of devices connected to the network. And if you talk about the reality, we have total, if you talk about one big company like Deloitte or Infosys or TCS, with their offices spread across the continents, and again within the city they got multiple offices, and in the same premises they got more than one building, you find the total network of TCS is a heterogeneous network, right? It has a WAN, and that too it has a point-to-point WAN, it might have a switched WAN, and within the city it may have a metropolitan area network, and in one premises it may have 1 to 2 buildings connected, which will be using a local area networks. So there is a combination of all these different forms of network, which we call it as heterogeneous network. I hope we have been clear with this. Right. Now the third part of your first unit is an important terminology called as internet. Now a big smile on everyone's face, because this is the most effective device or a tool of this particular century. We definitely call it as internet, which is been happening in making the demand for the mobile phones, right? Okay, so here we are trying to understand what do we mean by internet and what was the history of it, and who are the ones who are working for the creation of standards for this internet, right? Okay. In the previous topic, we tried to understand what do we mean by a network. A network is a set of devices which are connected by the links. For instance, I have 10 networks, network 1 to network 10. And now, if I am trying to establish a connection between all these networks, then it can be referred as internet. And the network within itself, how it is going to connect different devices within itself, we refer it as intranet. And how a network is trying to connect to the external world, we can refer it as internet. Got it? Intranet is within the campus or within the buildings or within the network. And when the network is trying to connect to other networks, we can call it as internet. In simple, people call network of networks as the definition for internet, right? And this presence of internet has made a lot of changes. The way business we do, at the same time, how we spend our free time, right? So let us try to understand where this internet has been started, and then we'll try to understand what are the standards which have been used for the internet. Coming to the history of internet, the necessity of connecting different devices in the network is identified in the early 1960s. What happened was the US Department of Defense was trying to conduct a research and was using the service of different universities. But all those universities were isolated and they doesn't have any kind of connectivity. So this impacted on the duplication of work that has been carried out and delay in the total work or the progress. So what happened is in mid 1960s, so mainframe computers and research organizations which were alone standalone device means they're working isolatedly. So the Advanced Research Project Agency ARPA was trying to develop a network to connect those four universities which are working on research for the Department of Defense. In 1969, they could successfully accomplish the project called ARPANET, trying to connect those four important universities: University of California in Los Angeles, and it is Santa Barbara and Stanford Research Institute, and the University of Utah. So this particular time, they tried to connect different devices as a part of network. It's a simple WAN network. They have been spread across. So this is the first network that has been developed, and that has been the reference for the number of networks which we are finding in the recent times. And in 1970s, the people who worked in this ARPANET project, they have developed a protocol called Transmission Control Protocol. And later it was been split into two units called Transmission Control Protocol and Internet Protocol. The Internet Protocol will be handling the datagram routing, whereas the Transmission Control Protocol will be functioning with segmentation, reassembly, and error detection. We'll talk about all this in the coming topics. Right. So what you are looking at is when you talk about internet at your house, the persons or the organizations which are responsible for providing us this internet facility, we call them as internet service providers. And based on their hierarchy of operation or the spread of operation, we categorize our ISPs into four levels. The international ISPs, which try to connect multiple national ISPs. A national ISP represents in one particular nation and tries to connect different regional ISPs. And a regional ISPs is trying to connect multiple local ISPs. And local ISPs are the ones who are actually providing us the internet facility. So this is on the organization hierarchy of internet service providers who are responsible for providing the internet to the individual customers. Now we talk about national ISPs representing different nations, and these national ISPs are connected to each other using a device called network access points, in simple NAPs. Okay, so when someone asks you about what is internet, what was its history, or what is the things responsible for the organizations responsible in the hierarchies, we can explain about all this. We try to understand what is internet, how it is implemented, what was the history, and what are the organizations responsible. Now, very important one, which you could just remember, we discussed this in our components of data communication called as protocol. A protocol is a set of rules and procedures that govern the data communication process. What do we mean by data governing the data communication is it determines what is to be communicated, how it is to be communicated, and when it is to be communicated. So when I talk about what is to be communicated between the source and destination, it refers to a terminology called syntax. When it is how it is to be communicated will be referred with a phrase called semantics, and when it has to be communicated will be referred to a phrase called timing. So a protocol, which is a set of rules and procedures that govern the communication. is made up of three elements called syntax, semantics, and timing. In simple, it is what is to be communicated, how is to be communicated, and when it is to be communicated. Right? So first, syntax. For instance, I got 10-bit info or 10 digits information, my mobile number, right? So my mobile number got certain meanings. If it is 919392461652, first plus 91 indicates the country. In previously, before we had this scenario of changing our service providers, the first 2 to 3 digits used to identify which particular network we actually belong to. The next it will be indicate, or you take our landline number 040 indicates the Hyderabad. Then the first 4 digits indicates the regional exchange, and last 4 digits of the number indicates the individual subscriber identity, right? So first what I'm trying to do is, so totally 11 phone numbers, 11 digits in your telephone number is a syntax. We divide into three parts: code, regional code, and your individual subscriber. Now what do you mean by STD code? What do you mean by regional code? And what do you mean by individual identity is explained in semantics. And particular, when you have multiple devices trying to communicate, when you have to communicate will be determined by the timing function and at what rate a data should be sent from the source to destination. And last thing that we have to discuss in our fundamentals related to data communications is standards which have been used for implementation of internet. So to have an open and competitive market, so we need standards so that we have open and competitive market, and standards actually try to help different modes or different manufacturers devices to communicate with each other. So I talk with an I'm using a Dell and my friend might be using an HP, but still both the devices need to communicate. And how all these communications, I'm trying to build a network with different types of or different manufacturers of devices, still they need to work. So we need certain standards. The standards which we have related to internet are categorized into two types. The first one are the standards which are developed not by someone legally, but it is being developed because of the frequent practice. Those standards which are developed by practice, we call it as de facto, whereas the standards which we are developed because of the law and its rules and regulations, we call it as de jure, right? And whenever you are trying to devise or propose a standard related to internet, it will be submitted uh, and need to be approved by certain organizations. So there are organizations which are responsible for creation of the standards. And what are those organizations we have mentioned here? The first and important one is standard creation committees. In this standard creation committees, we have IEEE, Institute of Electrical and Electronic Engineering, ANSI, American National Standards Institute, we have International Standards Organization, ISO, we have International Telecommunication Union, ITU. At the same time, we have some forums called ATM Forum and Frame Relay Forums. And then we have the regulatory agencies which play a very important role in the issue of licenses called Federal Communication Commission. We'll try to talk this in next topics. And generally, when you try to design a standard related to internet, it will be first submitted as a draft. And in 6 months, we can know the recommendation given to the particular standard submitted as a draft. And that recommendation is called ready for comment. So we propose a standard, convert as it as a draft and submit. And the standard organization committee will finally submit a report in form of RFC. Now, what are the possible values for this RFC ready for comment? The first one, required, means it says it's a very good standard and it has to be used by everyone. The second one, a recommend, means it's good. I can recommend it, but it's not mandate. It's good. Elective means we give the option to the customers to opt it or not. Four, limited use. I don't say that your product is useless or your standard is useless, but it has a very limited scope. if some more functions or applications are added, it could have become more effective. So those kind of things will be referred as limited. And finally, the fifth one will be talking about array this standard is stupid. This is of no use for us. So they say that it's not recommended. So this is how you are going to categorize your different maturity levels for the draft standard which you have submitted and which is called as ready for comment. I hope these are the 5 levels and you people are clear. And last thing before I end for this basics class is about layering scenario. In OSI model and TCP/IP model, I was referring that we are explaining the data communication in form of layers. So in OSI model, which is the first developed by ISO, we have 7 layers. And what exactly happens is namely we have application, presentation, session, transport, network, data link, and physical. Now, the source and destination, if we are talking about application to application communication, that will be referred as peer-to-peer. Peer means of same level. So the application of source and application of destination will be referred as peer-to-peer, and the protocol used there will be referred as peer-to-peer protocol, right? And each layer will be trying to get services of the layer which is below it. And the connectivity between the two adjacent layers, we refer with a phrase called interface. Got it? Peer refers to the same standards in two different devices, whereas interface indicates the relation between the upper layer and lower layer and the services offered by the lower layer to the upper layer. And when you have your source and destination were very far away from each other, then definitely we need to have some intermediate devices which help us in transmitting the data. One of the best examples for the intermediate device are the routers, which we refer as switches, right? So this is a simple way how a layered scenario exists and what are the different layers. In our next class, we talk about the two models, the different layers in it, and the functions of the layers, and also we talk about different types of protocols which are existing in each layer of TCP/IP model. I hope things were clear for today. So we try to start discussion with what do you mean by data, the forms of data, then what do you mean by components of data, then we discussed about data flow, then we moved from the data to the network. What do you mean by network? Then what are the types of links? Then we try to understand how we are evaluating the performance of our criteria network. Then we try to understand the categorization of networks as LAN, MAN, WAN. Then what are the types of links we have used, point to point and multi-point? What are the different types in which the devices are connected in the network called as topology? And after understanding this, we try to go for a network of networks referred as internet. What is the history of internet? And then we discussed about standards of internet and how we have been finally get recommendation for a particular standard, and last but not the least, the layering scenarios. I hope the things are clear for us, and definitely we'll have a good understanding of the remaining topics when we are clear with our fundamentals. Believing you people got things clear, and we'll hold our class with this. Let us meet in the next class. Thank you.